Okay, so this is then a chemistry required practical, which is called making salts. Now, what you're going to be doing in this is you're going to investigate how to make a salt and preparing a pure dry sample of copper sulfate crystals. Now, the equipment. So what I've done at the bottom is I've done 3 sets of equipment that you're then going to be potentially using. The equipment you're going to need is dilute sulfuric acid, copper 2 oxide powder that is black, a spatula, glass rod, measuring cylinder, beaker, filter funnel and paper, a small conical flask, evaporating basin and a crystallizing dish. All the equipment that I've just talked about is in this bottom section here. Now, before I move on, right, what you've got to also do is you've got to know what a salt is. Everybody always thinks salt is sodium chloride, common table salt. But what it actually is, it's a chemical compound consisting of an ionic. So it's an ionic compound that has a positive charged cation meeting up with a negatively charged anion. And what you do is when you combine those two together, you then create a salt. Now the method: measure 40 centimeter cubes of sulfuric acid and put into a 100 centimeter cube beaker of water, into a beaker. Right, so there what you've got is you've got your beaker and you've got your sulfuric acid in it. Heat it gently. Now obviously you've got to be very careful because hot acid is going to have more serious side effects. Right, if you get it on your hands, then you could then have a problem, so you've got to work very, very sensibly. Use the spatula to add a small amount of copper 2 oxide. So your black copper 2 oxide goes in there, and what it does is it reacts. Here you've then got to keep on adding the copper 2 oxide, and some of it remains after stirring. So you put it in, stir it, and eventually what you'll do is you'll see some black copper 2 oxide staying at the bottom, even after you've stirred it. That means the copper 2 oxide is then in excess. You've got more copper 2 oxide, right, or all the sulfuric has reacted. Then, when you've done that, what you do is you filter it, right? You put your copper 2 oxide and your liquid, which is probably a lovely blue colour, right, into there, and the excess copper 2 oxide stays in the filter paper. And your filtrate at the bottom is your copper sulfate, which is a beautiful blue colour. Okay, so what you do on this one then is you pour the filtrate from the conical flask into the evaporating basin, which is this here, and what you do then is you can then have a lovely blue. Then when you start to see crystals starting to form, stop heating it, take it off, and then eventually what you should do is you should see lovely blue copper sulfate crystals appearing. Now that is then making a salt, right? You've just got to remember it's pretty much a positive and a negative that join together to make the salt itself. All right, the method, there's a lot of description within it and a lot of equipment that's used, and probably the description of using the equipment is possibly the most important thing.
Now the next stage of this then is how do we make other salts? Okay? Because what we've done is we talked about copper sulfate. So if the question was how do we make potassium sulfate, right? Now you're also going to get water out of it at the end. How do you make potassium sulfate? You get potassium oxide, so instead of copper oxide, you get potassium oxide, and then you've got to look for sulfuric acid. So then what you do is you've got your potassium and your sulfuric acid, and you make potassium sulfate. How would you make copper chloride? Okay, now this is then changing it, because what you've got to do, you've got to think about your oxide, which again would be copper oxide. And when you're talking about the copper oxide, you've then got to think about an acid that's then going to provide your chloride. So this time what you do is you do hydrochloric acid. So copper oxide and hydrochloric acid makes your copper chloride, and your copper chloride then comes off as your salt, and then you get water out as well. Another example, copper nitrate. So what you've got to do, you've got to think about your oxide, copper oxide, and then you've got to think about your nitrate, and your nitrate is then which acid? And you've got nitric acid. Because nitric acid is HNO3, it's got nitrate in it. So you then, copper oxide, nitric acid makes copper nitrate and water. Last example this time is I want to make lithium nitrate, but I've got no lithium oxide. Now in the specifications, what you've also got is you've also got the fact that you can use a carbonate. Now, what I could do here is I could do copper carbonate and I could do nitric acid. Now this is again a little catchy thing here. If I want to make lithium nitrate, and I've seen this on an exam paper before, and they say copper carbonate and nitric acid, be very, very aware of what they give you, because they're going to try and catch you out. So it needs to be lithium carbonate and nitric acid. And again, the only difference is that when you're making your lithium nitrate and you're using a carbonate, you make the water that you've made in the previous ones, but this time you also make carbon dioxide. So you may well see a few bubbles that are then appearing. Okay, so just be careful about them catching you out. So now you've watched the required practicals. Now what you've got is your instructions about what you have to do. If you're unsure about anything to do with the video, then you need to go back through it. In the exercise books, don't write out the questions themselves. For shorter answers, just write out the answers that you're using in the question, and using the question rather. Longer answers, do a plan, make sure you get the right order, and then bullet point or small precise paragraphs. Don't do long reams of writing, it's not the way to do it. The questions are then on the next slide. Pause the video, and then when you've written the questions, review and see if it all